Thank you, everybody. I would like to start with a question. What causes all of these health problems? Cardiovascular disease, chronic insomnia, increased stress, hearing loss, and child development issues. The answer might surprise you, because this is something that we have all around us. Noise. Noise is actually an underestimated threat to our human health. It can cause problems for short-term and long-term. Actually, in a study made by the World Health Organization, they found out that in European countries, actually 20% of the citizens are exposed to high level of noise pollution that can cause all of these health problems and many more. Just for a reference, in developed European countries, the city noise level is about 60 dB, whereas the healthy standard is about 40 dB, which means we have 20 dB to go, which is pretty significant. The traditional ways to reduce noise are passive. For example, fences or foams or windows in buildings, or just earmuffs. But these have some disadvantages. First of all, they can be costly to engineer fans or to engineer new materials in cars. Second of all, and the most important, they are not effective in mid to low frequencies, which is actually the most harmful and most annoying to the human ears. That is why we created the active noise cancellation. Active noise cancellation actually produces anti-noise signals, which are kind of reversed to the original noise waves. So how it works is, we take the unwanted noise, we collect it by our microphones, which are sensors, and we transfer it to our algorithm. Our algorithm analyzes the noise, and it produces the anti-noise through the speakers, creating a quiet zone. So in practice, we have three different products that are based on our algorithm inside our ANC chip or ANC electric controller. First solution is made for household goods. We call it ducted ANC. The second one is called quiet bubble, or QB, for transportation. And the third one is called personal sound zone, for headphone-free entertainment. So I'm going to elaborate a little more on each one. First one is ducted ANC. Ducted ANC is aimed for products with a defined noise source. For example, HVAC or air conditioning, heating products, or cooker hoods, air purifiers, anything with a fan or a motor. What we do is we insert our system inside the products themselves so that the noise is treated inside the product and the noise is reduced before spreading to the environment or the user's ears. Currently, we have 4 products in mass production around the world. And here you can see an example of one of them. This is a cooker hood. You will see first the cooker hood without our technology, and then one with our technology. You can hear the difference. So the difference is about 6 to 8 dBs, which is very significant in a household setting. The second solution is called the quiet bubble, or QB. This is actually aimed for noises that aren't a specific source. For example, they are created in an environmental circumstance. For example, road noise in cars, or wind noise in trains or planes. We cannot we cannot stop the traffic, and we cannot stop the wind. So what we do is we create a bubble around a person's head. So in that specific area, we reduce the noise. For example, in cars, we just use the infrastructure of the existing mics and speakers to make quiet bubbles around the passenger's head. Currently, we have 6 car models all over the world in production. The third solution is our newest one. It's called a personal sound bubble. Personal sound bubble subdivides the environment into different acoustic sectors. Each sector can produce different sounds without disturbing the other. What it means is, if you sit in a car and you want to listen to a podcast, and your kids want to see a cartoon, so our product allows you to do that without any headphones, but you can't hear one another. So this is a complete privacy and just less annoying. So currently this product is introduced to automotive OEMs, and hopefully this will be in market soon. In the future, we hope that our application can be implemented in different scenarios. For example, cafes, hospitals, conventions, airports, and many more. Our goal is to migrate the noise pollution and create a healthy and serene future for all. Thank you very much.
Thank you.
So I'm really looking forward to the technology you just mentioned. So when I'm in my car with my daughter, if you wanted to listen to K-pop, I can listen to something else, right?
Exactly, yes.
So my question is, it seems to me, one way to position this technology is to use it as a value added to many of the other existing products and services, right? Like you mentioned, automobile,
Correct.
Or in an airport and in a kitchen. So what's your strategy in terms of signing up those complementers, so to speak, right, in order for you to penetrate the market? Can you share some insights with us? Thank you.
Thank you. Well, for penetrating the market, actually, because the increasing need of the voice commands for different products, for example, automotive or electrical machines in the house, that is increasing the need for noise reduction, because these functions are actually now working well if you have many noise in the background. So that's why many of the OEMs already approached us, and we are already in conversation and also in production with several of them. So we expect it to be increased in time. What else is, in automotive sector, they already have everything, all the infrastructure that is needed for our system. For example, the DSP chip, or the speakers, or the microphones. So actually, we can only just license our software for them to use. So this use is very easy, and the use time is very short. So this is for the automotive. Yeah.
Do I have time for one more question?
Yes, one more.
Yeah. So back to the car scenario. Sometimes the street noise may be useful for safety purposes. So what's your solution to that?
This is a great question, because this is a problem we're tackling. Actually, how our technology works is that it identifies the unwanted noise. It's only the unwanted noise that are treated by our system. Actually, when a person speaks, or if there is alarms or anything else in the street that is important, the frequencies are actually high. For example, above 1,000 hertz. But the annoying and the most bad noise for the voice commands and everything else, this is for the lower, like from 0 to 1,000 range. So this is the range the active noise cancellation is most good at. Yeah.
Thank you very much.
Thank you.
Okay, thank you very much.